So basically functions are a very important like math concept in general. And they're kind of like machine. You can kind of think of them as like you put in a number and they give you a number like back. So usually denote a function using the notation like f of x. And f of x just means like you have a function called f, and then you can put in variables, like put in numbers actually. You can replace x with stuff. So a function is basically any expression that for any one given input, you will exactly get one output. And that definition of a function makes like the definition really general. So for example, f of x equals like x squared minus 4 is a function. F of x equals like x to the power of 100 minus 72 is a function. Like you can even have like 2 over x plus like pi plus square root 2 over x to the 20. This is also a function. It's just a really weird function. So functions can almost be like anything. Of course, it cannot, like not all expressions are functions. Just know that like a lot of expressions are functions. Like any expression, if you have one input, you get exactly one output, then it's considered a function. And functions are nice because like we can kind of like represent expressions more compactly and more easily. So if I were to say like, for example, f of like 5, for example, what this would mean is I'm just replacing x, the variable x, with the value 5. So you would do 5 squared minus 4. So you would say f of 5 is 21. And you can just kind of plug in any numbers you like. Yeah, so the next thing about functions we'll talk about is it's like combining functions basically. And if you wanted to combine functions together, that's essentially like you would do exactly the same thing you would do like normal addition. So if you have the functions f of x equals x squared plus 5x plus 9, and the function gx equals x cubed plus 2x squared minus 2x minus 5, if you wanted to add these functions like f of x plus g of x, sometimes you might see it written as f plus g just for shorthand notation. Then you would basically combine all the x cubed terms together, all the x cubed terms together, all the x squared terms together, all the x terms together, and all like the constant terms together, basically. So you would have x cubed. If you were to combine the x squared and the 2x squared, you would have 3x squared. If you were to combine the 5x and the minus 2x, you get plus 3x. And if you were to combine the 9 and then minus 5, you get plus 4. So this represents the function f of x plus g of x. And the reason this is useful is now if we wanted to, for example, like calculate what f of like 2 plus g of 2 is, one way we could do it is we could just directly plug it into the first expression, plug 2 into the first expression, plug 2 into the second expression, add them together. Or we can just directly substitute 2 into this like new function that we created, and they'd both give the same result. And you can do subtraction in the exact same way. And if you wanted to multiply them, like it would basically be a similar idea. Like if you had like x plus 2, let's say you have a function f of x equals x plus 2, and you have a function like x squared equals g of x. If you wanted to multiply the two functions f of x times g of x, then you would just like multiply them like you would do normally with like the distributive property, like x plus 2 times x squared. You would just get x cubed plus 2x squared. And the last thing that I'm just going to talk about is like composition functions. Like it turns out you can kind of like put a function inside another function. Like you might say instead of f of x, you might see like f of g of x. Like you're putting a function into the input, and this might look kind of weird, but like for example, if you have like f of x equals 2x minus 7 and g of x equals 5x plus 1, like let's say you have two functions f of x, g of x, and just note like maybe I should mention this before, but you don't have to use f of x and g of x for the function names. Like you can use like anything, like a of x, b of x, like you can use like any name, but f of x, g of x are just common names, and you might see like h of x as well. So what f of g of x basically means is you take f, and instead of g of x, you replace it with 5x plus 1. So instead of f of x, you now have f of 5x plus 1. So we kind of treat this 5x plus 1 as like a big expression, and we replace this x with the 5x plus 1. So you would do like 2 times 5x plus 1 minus 7, and this would give you 10x minus 5. So that would represent the composition function f of g of x. And sometimes you might see people write the composition of the functions f and g, you might sometimes see as f and then like a circle g. That just means like f of g of x, basically.